Hello and welcome to this lecture. Today we are going to discuss teratomas, which is an ovarian tumor, and 20 to 25% or in some books 15 to 20% of ovarian tumor is caused because of teratoma, and it is a distressing feature of these germ cells tumor that is arising from the first 2 decades of the life. So it means that usually occur at initial age of life, but it could become worse at young age and get a chance to become malignant in the late stage of the age. Most of the 90% of these germ cells neoplasms are benign, mature, cystic teratomas, and their malignancy and immaturity varies. So if you see in my next slide, we mentioned 15 to 20% of the ovarian tumor is responsible for teratomas and have been classified into mature teratoma or immature teratomas. And when we talk about benign mature teratomas or cystic teratomas, it is marked by the presence of mature tissues come from the three germ cells, germ cell layers, ectoderm, endoderm and mesoderm. So this is a picture of ectoderm is the outer layer. It is also known as exoskeleton. Mesoderm, as the name indicates, meso is a middle layer that is responsible for the development of the organs, whereas endoderm forms the inner part of the layer that is responsible for the formation or lining of the organs. So that is the difference between them. This is a morphological picture of the ovarian tumor, such as especially teratoma, and this hair-like structure is actually this is the teratoma. So this picture I am going to show to you. Yeah, this hair-like structure is actually teratoma.
When you hear the word tumor, you probably think not good, and they can be pretty scary. In their mildest form, tumors are just a lump of cells hanging out in your body. At their worst, those cells are dividing and spreading like wildfire. They're cancerous. But there's one kind of tumor that's basically straight out of a horror movie. If you peek inside a teratoma, you might find hair, teeth, eyes, or even brain cells. As strange as those tumors are, the jumbles of body parts aren't actually turning into people. But they have taught us a lot about how stem cells and early development work. Most tumors start when a random mutation in one cell's DNA makes it go rogue and divide too much. So for instance, a lung tumor might be a cluster of cells that would normally line your lungs. If that tumor keeps growing, the cells can develop more random mutations, which can create more small differences between them. But on the whole, it's still lung-like tissue. Teratomas, on the other hand, look like you blended up a human and started growing something from that goop. And we think that's because of the cells that spawn these tumors. Most teratomas develop from germ cells in the ovaries and testes. Those are the cells that divide to produce mature sperm and eggs. As you probably know, sperm and eggs fuse together to make embryos. And the cells in early embryos have an ability biologists called pluripotency, which means that with the right physical and chemical signals, they can become pretty much anything, from skin cells to liver cells. If enough random mutations happen in germ cells, they can unlock pluripotency at the wrong time. Combined with wildly dividing cells, that leads to teratomas. As teratomas form, they have at least a tiny bit of all three kinds of developmental tissue that embryos have. There's the endoderm, which goes on to make your gut lining, the mesoderm, which makes your muscles, blood vessels, and skeleton, and the ectoderm, which makes your skin and brain. To be clear, they're not embryos. Their growth isn't nearly controlled enough. But that developmental tissue is how hair and eyeballs can start sprouting in these tumors. Scientists really started digging into teratomas in the 1950s and 60s. A team using mice to study the health hazards of cigarettes found teratomas in a mouse's testes, then switched over to tumor research soon after. Through careful experimentation with these tumors, biologists started to realize that embryonic development happened in a similar way. In embryos, it was just less broken. Plus, they discovered that mouse embryonic stem cells implanted into the testes of healthy adult mice could grow into teratomas too. So really, you can pretty much trace the field of stem cell research back to teratomas. And it's a field that could help a lot of people someday. Normally, it's hard to donate tissues to patients that need them, because our bodies reject foreign stuff. That's where pluripotent stem cells come in, like embryonic stem cells. We might be able to use them to grow tissues that can be transplanted without triggering those defenses, which could be really useful for medicine. But obviously, scientists don't want to accidentally transplant tissues that create teratomas. Even if it turns out to be benign, finding a tooth-filled lump inside you would not be a good surprise. So there's a lot we have to learn before these potential therapies get close to becoming a reality. And on that list is why seemingly normal embryonic stem cells grow into tumors with a bunch of body parts. Thanks for watching this episode of SciShow. If you want to learn more about weird things hiding in human bodies, check out our video on the natural painkiller in your spit. And for more of all kinds of science, you can go to youtube.com/scishow and subscribe.
And the ovarian cyst, actually they are of different types, and it could be mucinous cyst that are responsible for production of highly mucus substance. It could be dermoid cyst, which could be like hair-like structure. It could be hemorrhagic cyst, or it could be because of the endometrioid cyst, because of the backflow of the menstruation material or the blood, or corpus luteum, or follicular in nature as well. So again, there are different kind of ovarian cyst. So how they get discovered? Mostly discovered in young women as an ovarian mass, found by the radiography or the scans incidentally. So it is not usually diagnosable under normal circumstances, so it is diagnosed accidentally. Most of them are unilateral in nature, so it means it affecting only the one side, which is the right side. Unilateral mean uni is indicating the direction, so they are mostly affected on the right side. If you see this picture, they are morely moving toward this right side, so that's why they could be unilateral, affecting only the right side. The appearance look like the nodular projection from which white teeth protrude. To understand this thing, we need to see the structure in the next picture. This is actually, they are talking about a nodular projection. It means they make the node, and these nodes are actually look like the white teeth in color. So they are white in nature, their color is white. The appearance look like these white teeth that are attached. So they look like that the teeth is coming out from the ovary or from the mass, and they look like the nodular projection as well. So the appearance can be explained in terms of nodular projection from which white teeth protrude. Then we mention occasionally foci of the bone and cartilage nest of bronchial and gastrointestinal epithelium and other tissues are present. As we know that they are the mature tissues from the germ cells, which is ecto, endo, and mesoderm. So these some of these characteristics of the epithelium, like mentioned here, as the nest of the bronchial or gastrointestinal epithelium and other tissues are present, and bone and cartilage are also found. So you can see this, the bowl, the round structure, it could be combination of all of these tissues. So these neuroplasm are responsible sometimes for the infertility as well. This is another picture of the dermoid cyst. You can see the mucus secretion is found and the hair-like projection can be seen inside the ovary. Then we also have immature malignant teratomas, which is another kind of teratoma found early in the life, clinically detected at around 18 years of age. They form a bulk and predominantly solid on cut section, and they are punctuated by the area of necrosis. What is the meaning of punctuation or punctuated area of necrosis? It means in simple word that it contain necrosis. On microscopic examination, there will be presence of immature elements or minimally differentiated cells such as cartilage, bone, muscle, nerve cells and other tissues. And the prognosis of the disease depend upon the type or grade or stage of the disease. This is another picture of immature teratoma. So thank you so much for today's lecture. Hope to see you again.